Most people don't think much about how drip tape is made. They just want it to work season after season. But there's so much behind what makes that happen. And it starts here. Ttape was first developed in the US in 1977. Today, it's made here, in the USMCA zone of Tijuana, in Les Pinos, France, and also in Brisbane, Australia. Last year, it was sold in 57 countries worldwide. And since we're here right now in Tijuana, let's start with a conversation with the person in charge of this facility. I'm here with Vince Rogers, who's the Director of Manufacturing for North America. And we're here in this huge facility in Tijuana that's 160,000 square feet large. Tell me about your focus on quality.
Yeah, quality is at the core of our culture at Rivulis. And it's something that as we look to continuously improve and strengthen our operations, we lean on that culture to help us drive that decision-making process on how we make any changes in the factory. Manufacturing excellence isn't just about volume and speed, it's about precision and discipline on the lines as well.
Vince, you're new to this role. What does it mean to work for Rivulis?
It's something that I recognize that we're stepping into a really historic legacy. Ttape is the most widely used tape around the world. That legacy is something we take very seriously. When it comes down to it, when our growers are successful, that's how we become more successful as well.
But no matter where it goes, it starts with one thing: resin. Every batch of resin that arrives here is tested. This is one of the tests we perform. It's called Melt Flow Index. It confirms that the product will perform as required in the production process. If it doesn't pass any of the tests, it doesn't get used. Once the resin's approved, it heads here to the blown film line. Most Ttape uses blown film. That's different from extrusion, which is typical for drip lines. We create large reels of film by inflating molten resin, kind of like blowing a balloon, but with precision to 1/1000th of an inch. Before this film moves forward, we need to be absolutely certain it's up to strength. This machine stretches samples of film to test how far it can elongate before it breaks. It's one of the ways we confirm the strength of the material before it becomes Ttape. Now is where we see Ttape's true innovation, from film to finished product. But I have to say now, this is the secret sauce of Ttape, so forgive me, but we have to keep some of our secrets secret. But I'll try to show what I can. This is Juan. He's been the manufacturing engineer at Ttape for 33 years. Juan, what's going on here?
Well, I wish I can tell you, but it's a top secret. But I have a clear tape that I can show you. So we use a form wheel to make our pattern on our tape.
What you're saying is you select the form wheel according to the configuration needs, and it effectively prints out the inlets, the flow track, and the outlet pull area along this tape?
That's correct. We have many configurations of both spacing and flow rates to make our product.
As I understand it, because there's no dripper, there's no higher cost for the close dripper spacing.
That's correct. And the other benefit, it doesn't catch during installation.
And now we're at the end of our production process, and I want to show you a few things. What's happened is the tape has folded, and along the seam there is a flow track made by the form wheel. There's two important things happening. The first is, look at this where the seam is. This is effectively double thickness along the length of the tape, therefore providing extra strength in retrieval. The other thing is this outlet. It's knife cut, so it closes fully at system shutoff, which is important because, as you'll find, other drip lines for tapes have a hole or flap outlet or even laser cut, which is not as efficient in reducing soil ingestion. And here we are, the final product. Now comes the next stage of quality testing. Gustavo runs the quality program here. So Gustavo, can you walk us through the test now that the finished product is done?
Sure. In this machine, we test 6 feet or about 2 meters. And what we do is to measure the flow coming from the meters.
Okay, so each of these sections is collecting the water from each emitter discretely?
That's right. That's very important for plant uniformity.
Okay, the flow test is done now. What happens next?
Next, using the same sample, we increase the pressure from 25 to 50 psi or 1.75 to 3.5 bar, depending on the gauge and the product. And we hold it for 1 minute. The test is to ensure the integrity of the Ttape itself.
We've moved outside to see a new test that's done here in Tijuana. So Gustavo, can you walk us through it?
Sure. This is a test that we introduced in 2025. What we're doing here is we're testing larger samples of Ttape. We take samples from every active machine, from every shift. We take something around 100 feet. So we pressurize the samples so we can have another level of validation on every roll that we produce.
And here's the final product. So imagine that this product, first invented in California, has developed over many iterations to become the Ttape we know today. And from these resin pellets to final product, to every quality step along the way, providing the precise amount of water and nutrients to crops that are feeding millions of people every day. Ttape, the best by far.